second session of day one of a 3-day international seminar on Python and R programming, on data analytics and scientific computing, jointly organized by the Department of Mathematics, MOP Vaishnav College for Women, Chennai, and MathTech Thinking Foundation. I hope everyone had an enriching experience during the inaugural and morning technical sessions. We are delighted to have you all back for this afternoon session. We shall now move on to session 2, named Data Handling and Visualization. In today's data-driven world, the ability to efficiently organize, process, analyze, and visualize data is essential for deriving meaningful insights and making informed decisions. Data visualization further enables us to communicate complex information in a clear, effective, and impactful manner. The session aims to provide valuable insights into the techniques and tools used for effective data handling and visualization, which are indispensable skills in data analytics and scientific computing. Before we commence the technical session, I now invite Dr. R. Jamuna Sayyid, Assistant Professor, Department of Mathematics, to kindly introduce the resource person, Dr. Prayas Sharma, and formally commence the technical session.
Good afternoon, everyone. It is my pleasure to introduce our distinguished speaker of today's session, Dr. Prayas Sharma, and distinguished academician and a researcher serving as assistant professor in the Department of Statistics at Baba Saheb Bhimrao Ambedkar University, Lucknow. He holds a bachelor degree in computer science and statistics and completed his master's and PhD in statistics from Banaras Hindu University. He is a UGC NET qualified and a recipient of both JRF and SRF fellowships. Over a decade of experience, his expertise includes statistics, artificial intelligence, machine learning, business analytics, data science, and research methodology. He has published more than 100 research papers in reputed material in national and international journals, authored books, contributed book chapters, and received over 1,000 citations in H-Index and I-Index. Dr. Sharma serves as editor of reputed journals, including Scientific Reports and Discover Applied Sciences, and have reviewed over 250 research papers. He has delivered more than 50 invited lectures and received several honors, including the Best Teachers Award in the year 2025, Young Researcher Award, Outstanding Researcher Award, and Best Researcher Award with a strong foundation in statistics, analytics, and artificial intelligence. Dr. Sharma continues to contribute to academic excellence and impactful research, empowering students and professionals to harness the power of data-driven decision making. We are eager to benefit from your knowledge and experience in this insightful session, sir. Thank you, sir.
Thank you, Dr. Jamuna, for this nice introductions. And I would like to.
Thank you, ma'am. It's now my pleasure to invite our esteemed speaker, Dr. Prayas Sharma, to deliver the expert talk on data handling and visualization. Over to you, sir.
Thank you, Dr. Jamuna and the team for inviting me and giving me this chance to interact with the learning participants. I would also like to thanks here for Dr. Meher, who has contacted me and invited me for this lecture. Okay, so let me just share my slides so that we can move forward without wasting time. Yeah, I'm sure it is visible to you.
Yes, sir, it's visible.
Okay, great. Thank you. Uh, so today's session is what I was told earlier, that is based on the statistical computing and the data analytics using R. So I have divided this session into the two broad parts. One where we will talk about the R, how to interact with the R, how to do the basic statistics, basic programmings in the language R. And then moving forward, we will try to see a few things related to the statistics using R. That is, we may say the hypothesis testing, ANOVA, regression, correlation, etc. Right? And then we'll also do some hands-on practice on the given exercises, case studies, which we have prepared here. Before moving forward, I would like to share a few things with the participants. I think I can send these over the chat, and then you may use it. So one is the data set, right, which we will use here. The another one is the you may say the metadata of the data which we will use. What are the variables? How many there are variables? How are the what are the observations in fact, right? So these three, and the another file is the R file, which I am using for the probability distribution. So these are there. I have shared the three files over the chat. The participants can download this here, right? And then they will probably, they might use this wherever is required. Okay. I think there are some windows coming in between. Is this from my side or your side? I don't know. But this is interrupting and writing. Please move this window away from the shared applications. Is it from my side? Let me just stop
So
sharing.
we could see your screen clearly, so there was an intermission issue.
Okay, fine. Right. So, as I said, uh, uh, in the beginning, that we'll be trying to divide the lecture into two parts. One is where we talk about overview of the R and R Studio and how to do, the basic interactions with the R. And the another part, the second part will be based on the statistical sides of using the R, right? You may ask the question wherever you require, or perhaps you may ask at the end, whatever you feel comfortable. I have shared the data. I have shared the metadata of the data, and I have shared the R codes, the R file, which you might use for the probability and probability distributions, right? So wherever it is required, I'll ask you to use it, and then probably the participants can do along with me. If you have the laptops, please open your laptops and with these files get ready. Okay, so R is the, you might be knowing perhaps that it's an open source program, statistical computing and data visualization softwares. It means that it is freely available. When we say that it's open source, it's freely available and any one of us can be used. And that is why the popularity of the R is very much into the statistical sense, right? Because that has been that has been made particularly for the statistical analysis. And since it's freely available, we are trying to use it. And since I'm using the R for the last couple of decades, you may say, so I know that the R is very powerful, and most of the things which probably you cannot do in any of the softwares, that can be done into the R, whether it's a visualization, whether it's a statistical analysis, whether it's a hard coding, whether it's a hard kind of analysis, etc. Everything can be done. This R, to maintain the the regularity and comprehensive ARCAD network, the CRAN is there. And CRAN maintain its overall structures of the R. As I said, it's capable of running all types of statistical analysis, which probably other tools might not be easily can do that, but this can be done using the R. It's also enables the reproducible research because we can run the codes, we can see it again, and then probably we can see we can generate again and again the same kind of a structure, and that's why reproducible is that, which is one of the very, very important aspects of the research, the reproducibility, right? These are the few links where you can get the some of the materials using the R, right? I'll share this PPT and then you can use these links to generate and get the some of the uh, you may say the books, you may say the codes, the other structure, the case study, etc., etc., whatever is required here. These are the two very basic structures of the books, which probably would like to help you out while understanding the R, right, along with the statistical analysis. So far, we were trying to
Dear participant, please stay connected. Speaker has disconnected due to some reason and he is rejoining. Please stay connected.
Yes, sir. Yes, sir.
Also, I have the announcement to all the participants as we discussed in the morning. All the content and the recordings will be available on your account. Just you are required to log in your account, okay? And no separate link are we are sharing. All the information, all the links to join the session are there, okay? So we are not required to send again and again multiple links to WhatsApp group or on your email or WhatsApp messages. This is very user-friendly platform, and all the things you can also put your questions and communicate with us by putting your questions in the chat box as I show you in the morning. Okay, so if you have still any question or any difficulty, you can ask me.
Yes, sorry, I think I was late.
Yes, sir. Yes, please.
Because of the ban
Your
today, the internet connectivity. I have to share my PPT.
yes,
You
please
have
share.
permission, I
Sir,
think.
your voice is not clear still now. Your voice is breaking.
I think don't have the. I think I don't have the permission to share the PPT.
Okay, just 1 minute.
Check.
Mm,
I'm trying to. Yeah,
uh, Sir, now you can do. Sir, you can share the screen now.
Uh,
Uh,
yeah, I've shared. I think it's.
Yes, you can share now. Sir, also it seems to me your network is low. You can switch off your webcam. Only audio is enough.
Well, it's
Sir, are you able to share the screen?
Do let me know when it is stable. I'll start. Once it will be stable, means you can hear me properly. Just start delivering. I think it's still voice is
Yes.
unstable, right?
Yes, sir. Now it is visible.
Now it's visible, sir. Yes, sir.
Can you hear me properly?
So your voice is not audible, sir.
Yeah.
So we are able to we're able to see the screen, but your voice is not audible, sir.
But now, yeah.
Sir, are you there, sir? I think sir has got disconnected, sir.
Am I audible now?
Yes,
Am I
sir.
audible
It's
now?
yes, sir. You're audible, sir.
Okay, great. Fine. So, I'm if I'm audible, I think when I'm sharing the screen, I'm not able to.
Yes, sir. You're audible now, sir. The
Am
screen
I
is
audible?
also visible. Yes, sir. The screen is also
Okay.
visible. You're audible, sir.
Okay. Okay. Fine. 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 So we were here and talking about the R Studio, and as I said earlier, that the R Studio is a different GUI interface where we can use the codes, write the codes, run the codes effectively, and with the user-friendly interface, we can see how the codes are being run and what is the particular output on a single window. That's why particularly we are prefer to use the R Studio as compared to the R. It's helpful for the users, those who are first time users or the users, those who usually, use the R for both persons, right? So whenever I would like to advise you, I would like to request you that whenever you like to use the R, you may download the R. And for this session as well, if you don't have the R Studio, you may download till further. We'll start running on the R for understanding the different concepts. This is the 4 windows which we are talking about. So when you'll open the R Studio, you would like to see that there are 4 windows. One, the first left corner is known as the source. Right hand side, the upper right hand side is the environment, where you will see how the codes and which codes are being run, right? It means what is being executed, right? Because sometimes you may find the error. If the codes are not very correct, you may find the error. So many a times you will see that the errors are being shown, or many a times you will see that the codes is being run, means it is being executed, whatever you have written here. The left down left corner is called the console, where the codes are being executed. In the source, we can write the codes, we can change the codes, and that can save, right? But if we are writing something on the console, we cannot save it as it is. So usually what happens, we write the codes usually on the source. That means we open a new script and we write the codes, and then we run. That we can see in the environment. And if something is there, as you can see, files, plot, packages, help, and viewer, so we can see the outputs, what is being executed by the R program, our compiler, you will say, right? Fine. If you would like to say, you would like to change the pane, means from global to local, local to global, right? Then also you can do using this tool option available in the R Studio. We can also change the pane layout, right? You can go to the here in the pane layout options, console, source, and then you can see what would you like to see. Means if it is being executed, what would you like to see? So we have ticked on files, plot, package, help, and viewer. Other things are not required. Other things might required as a source, right? So we can do that. Means we can change the display option as we usually change in our mobile. We can also change in the R Studio, right? To make it more user friendly or to make it more comfortable as per the users, right? In R, we can type our commands in the console, as I said, right? We can write something new. And once we close the R, everything will type will not be able to save, right? Why? Because we have written on the console. Console is what? Console is a kind of compiler where we are generally compiling the programs. So therefore, if you would like to save the code, you have to write as a in the scripts that can be saved, that can be sent to someone, right? That can be used on a different computers, etc., etc., right? Okay. Now using this script, we have written a script, means in the input sections and the first left corner what I showed. So you can write the script whatever you want by yourself, and with the save option you can save this script. Usually we use the control and enter button, control and R button to run the codes, or you can also see that the run tabs is available here, and you can put on this run tab and the same codes will be generated. So for example, if I have written here X, okay, this symbol in the R is nothing but to save. It means we are saving it into the 5. Means 5 is being saved to X. 5 is a constant which will be saved into the X. So further, if you would like to see the value of the R, it will show you as a 5, right? Further, after that, you can store any other values to the X, right? That's how we write the programming languages. Okay, before you proceed further, you need to define the working directory. Why the working directory is important? Because if you will put all your files, data files, compiler into one folder, right, then running the codes, fetching the files, saving the files would be easier as compared to when you are not keeping your compiler in the folder where you would like to save the programs, right? If I'll show you later on, and you must have seen probably earlier if you have come across the R ever, that sometimes you write read.csv and the file will be fetched. Many a times you will see that the path is being given, right? So when your compiler, when you're working directly, is actually the directory where the compiler is being saved, then you need not to give the full path of the folder, full locations of the file. You can directly call the files by using its name, right? But if it is not there, then you have to write the full path. So that's the very good thing, that working directory will be saved. Another, that you know that your all files would be saved to an folder which you have prepared, right, which you made by yourself. So you can define this working directly, and you can use the codes setwd and getwd. So getwd is the what directly do you get, right? Means where is your working directory, and setwd what exactly you would like to do, right? Apart from this, you can also use here the session button and then get set working directory. So you can choose the directory and set as the working directory. That will help you to create the working directory, right? It's advisable that you put your working directory before writing the codes or before starting the codes, right? Starting the codes. This is the code here. You can see setwd C user BULUT desktop workshop 2020, right? So wherever you want to prepare, wherever you want to make a folder that will be utilized for all your R files, outputs, data files, etc., etc., that can be saved as a directory, that can be set as a directory, right? After that, if you would like to see that what is your directory, or even before that, if you type into your R getwd, it will tell you the path of the directory, right? If you are not happy with this directory, you can set a new directory. If you are happy, comfortable with this directory, need not to do anything, you can move forward, right? Okay. After that, in the R, the very, very important thing is the installing the packages. Why? Because many of the programs, many of the mathematical operators, many of the statistical tools, techniques, formula, etc., etc., are available into the different packages, right? Different packages. So unless you will recall, unless you will direct to the R that this particular package has to be called or fetch into your memory, right? If I talk technically of the the computer science world, so it is being archived, right? So from archive to you have to bring into your memory, and then once into your memory, then only you can be able to understand or see or manipulate or write or fetch, etc., etc., the files or code, etc. That is the importance when you say you are installing the package and then you are bringing into your working library as well, right? So for installing the package, install dot packages. For example, we want to use the ggplot, so I have written in the double bracket ggplot. I would like to install this package, right? So for example, this package is basically made for the graphics, right? So if you have to prepare, if you have to visualize the data, properly visualize the data, make the scatter plot, the bar chart, the box plots, etc., then probably you will use the ggplot2, and that will be shown to you that how the program, how the thing is being done. Okay. Okay, once the packages are being installed, right, means you have downloaded from CRAN and installed into your software, right? You need not to reinstall it after working sometimes or some days or some years even. Although a package is already in the R folder, it is not accessible unless it is activated, right? So what you need to do to activate these packages, you need to bring into your library, right? So bring to your R library, and then for this the command is library and again the package name. So package name was, for example, ggplot2, right? So once the package is being installed, you would like to run the code for the library that will tell you the ggplot2, right? uh Fine. In the R Studio, we can also fetch the file using this file, open file, and then file will be open, right? The another one, you can write the codes for the files which you require, write the path of the files which you require, write the path of the files which you would like to import into your R environment, right? And then you can use those files, right? So for example, I have given you the file for probably the medical file, right? Where the medical data has been given, right? So you have to call that file wherever you have saved. You have to call that file into your R environment, and then probably you can start working on it, right? Lastly, once the package is being installed and activated, right, you need to you need to work on this for the formulae, for the data, for the other things which is available in the package, right? You cannot do, or even you cannot use those things which is not in the package. Different packages have the different kind of the analysis data, the analysis experiences, the analysis visualization uh, codes, right? So whatever package you are installing, right, only the things which is available on that package can be utilized, can be worked on, right? Now, once you have installed the package and bring into your library, once you called into your R environment, you can run the codes, right? Then the codes would be run. If these are not installed, the codes would not be running into your R, right? Now, now you are familiar with this with the R environment little bit, right? So you can open the R Studio along with me, and then these are the basic things which can be utilized, right? So for example, if you would like to create a new variables into the R, right? You can use the assignment operator as assignment operator given in the R, right? Or you can also now use the equal to sign, because that's also available in the R, which can be utilized, right? Just give me a moment. Hello. Yeah. मैं बिजी हूँ थोड़ा एक मीटिंग में आपसे बात. Yeah. So to create the assignment operators, you can use this sign or equal to sign even nowadays, any of the variables, right? So for example, I would like to create x equal to 1 or assignment operator 1. That means 1 is being installed into the x, right? You can use or probably simultaneously, so that you can have the understanding how to do, and even you can build up the confidence of writing the codes into the R. Those who are familiar, probably these are the very basics, they know it very well. Those who are new to this R environment, the R programming language, they can even run these codes, right, and get the exposure of this. If you have any questions in between, you may probably ask. So for example, we have created x, right, as a scalar quantity, 1 is being saved. Now you can create the vector quantity or the multiple values into the R. And what is the command? Command is C, right? So we are trying to store the weights of the 5 people, right, into the variable name weight, and C stands for the combine. So we are combining 60, 72, 80, 84 and 56 into the weights. Now, once it is being saved, if you would like to see the weights, you have to again write the weight, and that it will run the weight, and then you will show what are the weights is being stored. Similarly for the heights, right? So whenever you would like to enter the smaller data, right, to deal with or to to do something along with that, then you can use this combined structure, and then you can save on it, right? Can anybody of you tell me this is the small c or the capital C? Anyone? You may write in the chat box, no worries. Small c. Okay, fine. And if I write the capital C here, Mr. Ravi Shankar said that it's a small c. It's a correct answer that the small c stands for the combined, right? If I write here the capital C, what will happen? Is there some difference when I write it the capital C? It will not work, right? Why? Because it is a case sensitive language, right? In the beginning, probably I said that it's a case sensitive language. So it's case sensitive means it's put focus on the smaller case and the capital case, right? The larger case. So it understand whether it's a small c or the capital C. If you write the capital C, it won't understand what the C stands for a specific function combined, right? So it won't work. So keep this in mind that this is a case sensitive language, and it will not work unless you will write the correct scripts. So once we have created a variable, we can do the further calculations, further anything whatever we would like to do into the R environment. So for example, if you would like, so weights were there, right? And if you like to multiply your weights with a constant, for example 2.2, right, and would like to save into the another variable that's called weight 2, how it can be done? Weight 2 is equal to, or the assignments operator, weight multiplied by 2.20462. Now, since the weight was a vector quantity means it has a multiple entries, right? So it is being, all those entries being multiplied by the 2.2, and a new variable is being created as the weight 2, which is available in front of you. Again, if you'd like to multiply this weight into with the weights, will it work? Will it work? Weight and the weight 2, and if I use the weight and multiply the weight 2 by 2.2, what will happen? Anyone? Will it work? I think I'm audible, right? Okay, fine. So this here, there will be a new weights available. As I said in the beginning, you can store the constants again and again into the same variable name. But when you have updated it, it will always show you the updated one, not the old one, right? That will happen. So now the new weight will be older weight multiplied by 2.20462, right? And that can be done. You can redefine your variables of existing, for example, reading, C, math, total, reading plus maths. That can be done, right? These are the very basic concepts of writing, or the when you have started writing the codes into the R. These are the few things which you can create. Now if you'd like to create the variables here in the R, how can you do that? You can write, for example, if you can store the name of the different cities into a variable called cities, right? How can be done? Cities, where is the variable that's available on your slide, you can see easily. What it need to be combined, the name of the city. So name of the cities means the character is always being written into the double inverted comma. So that what have been done. How many are there? 5. So now cities is the variable which has been stored the name of the 5 cities what is being given, right? We can also treat, this is the character, right? Now the character is being saved. Now cities is the variable which is saving the 5 different names of the city. The numerical values can also be saved as a character sometimes, right? For example, if the numerical value is showing the category, not exactly the numerical values, then it will be treated as the character. And for example, 1 is male, 2 is female, right? Or 1 is pass, 2 is fail, or 0 is fail, 1 is pass, whatever, right? We come across many a times such variable, such data sets even, right? So that can be used also if we write into the inverted comma. So when we write into the inverted comma, it will consider it as a character, not as a numerical value which can be added or subtracted, right? And for anything which you know that we have to produce here the gender. Right. So as I said, the R is scan sensitive. So once you have written the cities and you would like to see the name of the cities, what it means is stored. So you have to write the cities, right? And in R, when we write the name of the variable and press enter, it runs, right? So it shows you what is being stored into that particular variable. If I write the capital cities by mistake, right, it won't say that it says that the object is not found, right? Why it is saying for the first one, I understood for the second one, that is the the capital letter. Why it is for the first one? Anybody can tell me? Why the first one, cities, is not found by the R? Yeah, someone has responded to me. First letter is capital. Yeah, very correct, Mr. Ravi Shankar. That is the first letter is the capital C. And what happened? The name is being changed, right? That R doesn't understand what is the cities with the capital C. It only knows the cities with the smaller c, right? That's what the problem is. Fine. So while defining the variable names in the R, you have to keep two things in the mind, that it cannot be begin with a number. So means variable name cannot be begin as a number. For example, if I write 5 cities here, 5 and then cities, it cannot be a valid variable name. Also, the variable name cannot have the space, right? So whenever you write whenever you write the variable name, you have to keep this in mind. It cannot be started with the numbers, cannot be used, or cannot utilize this space in between. So 4 cities, 5 cities is not a correct name. Also, my space cities is not a correct name. It's not going to save, right? Fine. How can you convert the things into the different one that we are going to see here? Naming conventions in the R. All lowercase. Example, my cities, period, separated, right, can be utilized. My cities underscore separated can also be utilized. My cities number at the end can also be utilized. My city 2008 can also be utilized as a variable name, right? Combination of some of these rules is my.cities.2018. So these are the names of the variable, right, which might be able to tell you the understanding of the creating the variables, why it is made for, what it is being made for. Then you can understand, not to create the messy codes that is difficult to read and understand. And I recommend using the consistent and clear naming of conventions. For example, the cities, right? For example, the cities. Also, as you know, it's a lowercase and uppercase issue. So try to write everything in the lowercase. Why? Because majority of the things in the R is available in the lowercase. Only few of the things are available in the R which is being utilized, or which is available into the capital letters of the English, right? Most of the things are available into the smaller one. Commenting in the R, many a times you will see that you want to write something, right, which is not being executed, right? Just for your understanding, you would like to write, right? In many of the times you must have seen that some codes are written, and above the codes there are some description that what it is made for, right? Why it is made for, it's being written. And that can be used to write with the hashtag symbol, right? So hashtag symbol is nothing but the symbols which can be used for commenting in the R. Any word, codes, etc. coming after a hashtag are just ignored. Ignored means it is not being executed, right? It won't go to run into the compiler, right? So you can write anything, right? For example, I am writing a program to get the $100, right? That can be a description in the title, in the over the title, that what are you going to write. This is script for 4 pages, 5 pages, 1 pages, etc. That can be done. Similarly, if I would like to, okay, so when you are writing the codes and using the hashtag, it means that your codes are very well written. In what sense? In the sense, when somebody else is going to read your codes, then he'll able to understand why a particular line is being written, because you have already mentioned the purpose of writing the writing those codes or those lines with a hashtag, right? This is also useful when you would like to see your codes even after years, right? What is being done. So you can remind while seeing the hashtag and the comments that what exactly you have written these codes, right? You can easily comment out a line without having to remove it from your codes, right? For examples, these cities are written over here, which you can see. Now, importing the data into R. Importing the data into R is very, very important things, because you can analyze the data. You have an idea to know the statistical capacity, statistical understanding. But if you are not able to bring your data from the different environment, how you are going to analyze the data, right? So most of the data sets are nowadays available into the text format, the CSV format. If there are some, the numerical data will be available into the Excel format, that format, right? So how you will bring those data? So bringing those data have the different commands, right, which can be utilized to bring, or import rather is the correct word, for importing the data into the R environment. using the different data formats, right? So if it is text, you will bring the text. If it is CSV, it can be, you can bring the CSV, and then probably you can convert it again, right? You can utilize this again as per the convenience, right? So two possible ways to read a data files into R. One is import the data set, right? Menu option means menus. There are menus available which I've shown earlier. The options are available. You can import it, or you can write the R command to import particular file, right? When you are writing the commands, when you are using the R, you are expected to write the commands for the everything, right? Because you might be able to perform some data analytics jobs later on, the coder jobs later on, right? And then you will be expected to write the codes rather than putting your cursor here and there. Now the situations are changed a lot, right? But still, writing the codes is faster than for looking anything else and then creating your own thoughts on it, right? So this is the console which you would like to write under the files. So import the data set here in the files, import the data set from Excel, from SPSS, from SAS, from Stata, etc., etc. So whatever be the format you can use. This is one. Another one, you can write the codes. First of all, install the packages. XLS is a package where the XLS file, their reading styles, their reading codes are available. So you have to install it in Fabric and bring it to the library. After that, you can create the names like this: my underscore Excel underscore file, right? Because you know that you cannot write my space Excel space file. That's why the underscore is being placed here. Next, read.xls means the original file which you would like to import is of Excel type, right? And then you would like to put the path of the file. Path of the file means where it is being stored, where it is being stored. That is called the path of the file. So if you would like to bring the Excel file, XLS, if you would like to bring the SPSS file, it's foreign, right? Foreign can to bring the file. Okay. The another one, you can also use the CSV file. All these names are same. What? Path of the file, wherever it is stored, if it is not stored into your R directory, right? If it is stored into your R directory, you can directly write the file name into double inverted comma and you can bring that into the R environment. Is it clear? Any questions so far? Okay. When we are using the header, you can see here I have used the header is equal to true. We'll also use in the coming, hands-on experience. So header is true means the variable names are in the first row written, right? Why? Because then only you will be able to understand what you are seeing the data, and what it is exactly for. So that's what the header is true. If you'll make it false, what will happen? You will not be able to see the header, right? So if you know the data very well, probably, or you are doing something where you require that the data means the first line cannot show the variable names, then probably you can use it to false. Otherwise, in all other situations, please make it true so that you can be able to understand the data very well, right? So here in the coming slides, you will find the files medical.csv. I've already shared with you, right? And this files medical dataset comes from a clinical trial of adding inpatients recruited from a detoxification units. They are coming from the detoxification unit. Patient received either a multidisciplinary assessment and a brief motivational intervention or usual care. The dataset has several demographic variable as well, which I have already shared with you in the starting, right? And this is the source where you can easily find all those data sets and the metadata of the data sets. Right? You can means we can probably use the medical.csv file, right, and import these files into the RStudio if you would like to work on it, right? So using the codes under the exercise 2, you will read the medical data into the R. So if your next exercise is to bring the data into the R, right? If there is no error message in the console, right, your data set is being properly came into the R environment, and then the variable which you have saved that can be utilized with the variable name. Okay. Yeah. So once the data set is imported into the R, we should ensure that the R was able to read the data properly, and the command prints out the first 6 rows of the this data shows the uh, first 6 rows of the data set. Which command? Head commands, right? So if I write here medical read.csv medical.csv header is equal to true, right? Is that going to work? Is this code is going to work? I would like to get the response from the audience, right? What do you think about this code? Anyone? The first code is written medical assignment operator read.csv medical.csv, right? Okay, fine. Yeah, that's the right answer. Medical.csv headed true, right? This code will work if your directory is the same folder where the medical.csv data is saved. If not, like for example, in my case, it is not saved into the directory, right? I have saved into the D drive, R16 folder, R, and the 16 is the date. And then I have saved the medical.csv header is true. So I want to bring this file into the R environment. So I'll run this code. Shall I run it simultaneously? Yeah. Let me just open my R here and let me run it, right? I'm opening it and I will show you that how can you bring. Please, those who are new, particularly, are there things that they are not very much familiar with the R. Please do along with me, right? It will certainly give you the better experience, the confidence, etc., etc. Right? Few of the packages I have already installed, right? So I don't need to install those packages, but you need to install those packages, right? What are those packages? I will tell you later on If nothing works, any in between, you can let me know and I'll tell you. First of all, let me just bring this data into the R. Let me just clear it. Are you able to see my screen? Not yet. Is it visible?
Yes, sir. It's visible, sir.
Okay, fine. So in my case, if in your case, I don't know where your data is being stored, right? But in my case, I know my data is into the D drive, a folder R16, and then medical.csv is the name of the file, right? Medical is the name of the file, extension is CSV. So I can run this code, right? I can run this code here in the console, right? What happened? When I run this code, what happened? There is no error message, right? Nothing. It means the code is being executed, right? It's already available now into my R environment, right? Let us see here. Head, head, and then medical, right? You know, head medical shows the only 5 responses, right? 6 responses. So it is being given here the 5 responses to me, only first 5 responses. And I have shared uh, you know, a PDF file with you, which says the code book of the medical data set, where ID is the patient ID, age is the patient age, sex is the patient gender, whether male or female, race is the patient race group, black, other white, etc., etc. Homeless, whether patient is homeless or has a house. Substance, primary substance of abuse means alcohol, cocaine, or heroin, what is being consumed. Average drinks, right? Average number of drinks per day during the last 30 days. Max drinks is another variable name which shows the maximum number of drinks per day during the last 30 days. Suicidal, whether patient had thoughts of suicide in the last 30 days, right? Yes or no. Obviously, it will give you the data into yes or no. Treatment. Treat is the variable. Whether the patient has accepted to help clinic, yes or no. Physical one. Physical score at baseline. High score indicates better physical status, right? Mental one. Mental score at baseline. Higher score indicates better mental status. Now we have the depression 1. Okay. And what does it say? Depression score at baseline. High score indicates more depressive symptoms. Physical 2. Physical score after 6 months. Mental 2. Mental scores after 6 months. Depression 2. Depression score after 6 months. So these are the probably 16 variables which I have shared with you, right? And these are the 16 variables. Uh, you know, you can see that the output is given. So ID is 1 to 6, their ages, then sex, then race, then homeless or home, etc., etc., right? So with now your medical data is in your R environment. How many of you have kept this into your R environment? Can you just tell me? How many of you have kept or brought the medical data into your R environment? If I would like to see the structure of this data, right? So str is the command, and then data is medical. Data is being stored into medical. Control enter, right? Control enter, and you can see here that is being run, that is being executed, right? So ID is an integer, age again is an integer, sex is a character, right? Race is a character, homeless is again the character, average drink is integer, etc., etc., right? Physical the numbers, mental numbers, depression integer, right? So wherever you can see that it's the numbers or the integers or the, the both, right? Can you just tell me confirm on the chat box that you have imported your medical data into the R environment? You have imported the data into the R environment. No? If you have any problem, you may tell me. If not, I'll just proceed further, right? So for example, if you would like to know the age, right? And age is one of the variable which is available in the medical data, right? And you would like to know the age which is available in the medical data, and you want to get the first five ages in the data, right? So for five head, the command is head. Now, for not all the variables, if you only put the head medical, it will give you for all the 16 variables. If you'd like to only see the age, head medical, and then dollar age. Dollar is used to access the individually, individually the one variables, right? So I'll enter it here. You can see here, my console is visible. I probably see, I think, 37, 26, 39, 32, and this one. Fine, right? Good. Okay. Similarly, if you're not doing with me simultaneously, probably I'll just share my PPT, and later on you can run these codes. I'll share with you. So that would be much convenient for you understanding my thoughts. Just a moment. If you're not comfortable right now, right, you may just do it later on, right? Because that will give you the right. Fine. So now the slides are visible again. So medical data, again, head medical, and you like to add something, means probably you will only like to see the first five age, sex, and home list, whether they are first five ID people have what are their ages, sex, and home list. For similarly, you can do that. So head is a command, medical, see, you have to combine these three variables which you would like to see, and then you can do that, right? Similarly, if you would like to see from 1 to 5 and then 1 to 3, so first shows the rows, second shows the column. So first 1 to 5 and 1 to 3. This is nothing but the sequence. So we started writing in colon type the sequence in the R. So medical 1:5 rows, 1:3 rows. You can do that. Similarly, the same thing can be done. Medical C 1 2 3 4 5, C 1 2 3, right? Medical 1 to 5, C ID is sex, whatever you would like. First 5 and then second one C. So first, when you're writing in this way, the first word shows the row, second one is the command. There are multiple ways of writing the same things in the again and again. So where there might be a probability that you are writing a codes in the 10 line, your neighbor can write the codes in the 5 line or maybe 6 lines, right? Why? Because the same task can be done using the another command, using the another way of writing the commands as well, right? Okay, so for example, if you'd like to create a new data sets, right, which only contains the females from the medical data set. What it can be done, medical underscore female is the name which would like to save the data into. Subset, right? Obviously, subset is that medical comma sex double equal to female, means sex will save check double equal to female. So those who are female, those only can be stored as the sex. That can be done. Okay. Or the another way is medical sex can be stored as the female. Both are the options can be done. This equal to sign actually is not an equal to sign or not the assignment operator. Rather, it's a logical operator which said that the conditions are verified. So if it is equal to, save it. If it is not equal to, don't save it, right? Again, male 50, right? So subset medical sex is equal to male and age is less than 50. So you can save, you can prepare the data, you can prepare the subsets, you can do the data mining. This is also called the data mining with these codes, right? Recording variables, recoding variables, medical is to, if else medical is less than 50, 50 plus 50 or younger, you can save it medical and age 2. So there are many things which you can bring from the data, right? And you can prepare the data frame, prepare the data set, subset of the data set as per your convenience, right? So that's what I would like to tell you here for these examples. For category variables, you can write tables medical 6. How many females and how many are males if you'd like to see. On which variable? 6 variable. Suppose I want to see again this now on homeless variable. So medical under medical dollar homeless. Dollar is a sign which tells you, which offers you, which give you the liberty to interact with the specific variables under a data set, under a data frame. Now, if I comes to the descriptive statistics, if you'd like to know the mean, median, variance, standard deviation, range, etc., etc., these are the commands here available, right? Those who are doing with me on the R, they can put these commands, right? If they have the medical data into the R environment, and they will get the same values because the same data is being given to you, right? So if you'd like to see the mean age of the people who are there in the medical data sets, you can write this command. Median, you can write this command. What are the standard deviation of the ages? You can write these commands, right? What is the minimum age? 20, you can see here. What is the maximum age? 60, you can see that, right? Similarly, many things also can be seen. If you'd like to see for the, mean of medical age and medical sex, and you would like to prepare a table, you can use these commands, right? Tapply, medical ages, medical sex, mean, average of these two are here. Median, tapply, here the median is that, right? What would like to apply? SD, you can get the SD. Variance, you can get the variance. So table along with apply, what measure you want, that is being written at the last, right? This is how we can write. Okay, so descriptive statistics by the group also we can create. For this we need another package, skimr. Use the library, then you can use the function skim medical C, right? And then the skim summaries is available. 5 variable, 246. Why only 5 variables? We don't have the 5 variables. Why it is 5 variable? Anyone? Because for this we have specifically given the 5 variables. Data set medical, but only use these C5 variables. That's why the 5 variables. All those rows, right, has to be taken, but the column is only 5. These variable names, right? So here it is being given. How many are missing values? 0. Completed? Yes. What is an? Yes. Minimum is 4, 6. Maximum is 8. empty 0, number of unique 2. So this is how we can prepare the data sets. We can use the data mining, right? We can utilize the different data sets. If I have to do some analysis only on the females, right, we will separate out the female data and perform some analysis. If I have to do this analysis on male, we can do that, right? Male with the age 50 plus, we can do that, right? So how you can segregate the data as per your convenience, as per your requirement, that's what we were discussing here. Now, if we let us see quickly the visualization, box plot and histogram, right? So box plot and histogram are the two function names here, right? If I need to see the box plot of the depression 1, right? Depression 1 is a variable which shows the depression. Definition of the variables are written into the file which I've shared actually, right? So medical depression 1, this is the box plot, right? What do you see? What is the average depression? What is the average depression?
Around 35.
35. Good. And what do you see when you are seeing this box plot? The middle line is towards the right side, not in the middle. What does it mean? What does it mean? Similarly, you can see the histogram. What does it mean?
The data is skewed to the right.
The depression is higher, right? Is in the higher side, right? It's not the average in the people. Depression is in the higher side. That's what this box plot and the histogram is telling you, right? If I need to say box plot by the groups, right, by the males and females, what do you see? What can you conclude here with the name male and female? Depressions in the male and depressions in the female. This is the code which you can, use to generate these two box plot. What do you conclude with this? Anyone? Depression levels, okay, I think you can see that the first box plot is the female, the second one is for the male. What can you conclude?
We can say that on average, more females are depressed than the males.
Sorry, I couldn't hear you. Can you just repeat yourself?
On average, the females are more depressed than the males.
Right, exactly. The females have the more depression, right? Why more? Because I'm seeing that the depression level is higher, right? More depression than the male, right? And you can see that not only this data set says this, right? But you can also see that into your real life as well. That most of the times you see that the depression problems are being faced by the females. Why? There is a logic, but I don't want to go there. That's just let us just stay on these data sets. Okay, so scatter plot and the bar plots for the depression one, right? You can see that depression one, scatter plot, and the mental one. Mental one and depression one. Can anybody tell me what does it mean? What does depression one shows and what does mental one shows? Hurry up. What was that? given you the PDF file. It's given there. Right? Okay. Anyways, so here we can also generate the scatter plot, right, and the bar plot using the male and females. For what? The second bar plot is the frequency and the number of sex. Who are there in this data set? Males are there. There means males are higher than the females in this data sets, right? And that is here is their mental level and the depressions, right? So mental 1 and the depression 1, if you will plot it here, it shows 1. What does it mean? What does it shows you? What does it gives you? Which kind of correlation do you get? Which kind of
Yeah.
correlation do you get between the mental 1 and the depression 1?
The scatter plot examine the association between depression and mental health. So the bar chart compares gender frequencies, and the histogram would display the spread on numerical like depression scores.
Mental 1 is the mental score at a baseline, right? Higher score indicates better mental status. Depression was the depression score at the baseline. Higher means higher depression, right? So there is the negative correlation between these two. Obviously, higher depression means lower mental level, right? You're not fine, right? If your depression level is higher, you're not fine, right? Other way, if your mental level is high, your depression level is low, right? Very, very low, right? That's what it means. Okay, fine. Again, if you like to plot the depression 1 data here using the library lattice, right, you will see that this kind of a histogram. It means the depression level is little higher in the data set, right? It's not in between, it's going the higher side. That's what. By the groups, you can see the males and females. Again, in the males and females, you would see that in the females it's a higher towards the higher side, but in the males it's usually the the normal structure shows, right? The normal structure showing the depression level. You can also use the XY plot between the depression 1 and the mental level, which we have already done. This is a beautiful plot. That's why I would like to show you. You can generate the similar one. Along with this, you can segregate this with the use of the alcohol, cocaine, and heroin. Alcohol, heroin, and cocaine. Those who are consuming this, right? What do you see? What do you conclude here? Definitely, all of them has a negative correlation, right? The lines are going towards the down. But what do you see? Means can you segregate? Can you differentiate between them? The slope of the line, if you draw in the alcohol, cocaine, and heroin, the slope are very sharp in the heroin and then cocaine and then alcohol. Do you agree with me? Do you agree with me? Yeah.
Yes, we agree.
What does it mean? It means the cocaine and the heroin is much affecting on your mental health as compared to alcohol. Am I right? Fine. The another graphs can also be generated using ggplot2 with respect to the depression 1, right, and the male and female. So red one is the female and the green one is the male, right? Another kind of graph means in terms of the beautification, in terms of more attractive, more the graph is attractive, probably more you can draw the inference on it, more information can be gathered, right? So this is the depression level and the mental level. Again, you can see that male and female wise, if you see, the scatteredness in the male is very, very high, scatteredness, right? But the scatteredness in the female is little low as compared to the male, right? Again, it comes when is higher, the scatteredness is higher. Again, it means the slope is higher, right? So slope in the case of female is quite sharp as compared to male, right? Which we have already seen earlier, right? Again, the depression with respect to the females and males, categorizing into the groups alcohol, cocaine, and heroin. Alcohol, cocaine, and heroin, right? We have already seen it, right? Just draw the line to make you more understand, right? And how you can perform the analysis into R, that it was also the objective. Right? So you can create this using this concept. You can also create later on the histogram and the other exercises for data 2, and you can also create the the scatter plot and try to understand the relationship between the depression 2 and the mental 2, right? I hope you are remember what depression 2 stands for and what mental 2 stands for, right? If you are not able to know the meaning of these two, probably you will not be able to understand what exactly they means and how that's going to affect it, right? Fine. Let us see quickly the hypothesis testing, right? And draw some of the inferences based on the medical data. I understand and I believe that you know some of the concept of the hypothesis testing. If not, I'll just quickly tell you that hypothesis testing is nothing but the formation of the rule under which you have to accept or reject the null hypothesis, right? What is this rule which you have to formulate? You as a researcher can formulate a rule that I will decide this confidence interval, I will decide my null hypothesis, I will decide my alternative hypothesis. And before starting the process, before starting the testing process, we'll fix all those things. And then I will start the process, right? And then I will decide the whether hypothesis created in the beginning is being rejected based on the samples, based on the process, or not, right? So there are three different tests: one sample test, right? Two sample tests, independent sample test, and related t-test, and then ANOVA that we will see. For example, here if this for medical data set, if you see the metadata, you will try to means you will get to know this, right? So for one sample test, let us understand all the patients in the medical data set received a mental test at the baseline where they were accepted to the study. Obviously, you know, as a researcher, when people are involved, you have to take the permission for the study, and then medical test is being happened, and then their medical score is being stored, recorded. The researcher who created the mental test reported that the mean score on this test for people with no mental issues should be around 35. Now we want to know whether the mean mental test for our sample of patient differs from the mental level test score for the general population, right? So mental score 35, whether it is true for the general population or for only population which we have taken, the data which we have taken. So mu is equal to 35 As a null hypothesis, alternate mu is not equal to 35. Let us see the average of the mental range. So we have put this into the R, mean medical dollar mental one 31.68. So 31.6 is the actual value. So it looks like that our sample mean is less than the population mean of 35. But the question is whether it is small enough to conclude that there is a statistically significant difference between the sample mean and the population mean. Though our sample mean is less, but can we conclude this that it is less for everyone? What do? We do the test. Which test? One sample t-test. What is the command? T.test. What we are trying to test? Medical one. Where it is stored? In the medical data. So medical under medical dollar mental one. Mu is 35. Confidence level 95%. Alternative hypothesis is two-sided, right? So when we test this, you know, the alternative hypothesis is two-sided means what? It can be more than 35, it can be less than 35. If I would have taken as mu is greater than 35, that it was a one-sided. If I would have written mu is less than 35, it would be one-sided, right? Okay, fine. When we run this code, one sample t-test data is here. Alternative hypothesis 2 mean is not equal to 35, right? 2 mean is not equal to 35. What does it mean? Anyone? The null hypothesis is being rejected, right? It means that the population mean and the sample mean is not equal. Their mental levels are different. We cannot say that the mental level of this data set of medical or the people those who are there are same with the population, right? This is the another way. One sample t-test is the another way of performing the same analysis, right? And here is the result and the confidence interval. This is better in terms of the interpretation, nothing else, right? This is the another example of one sample t-test, right? Since there is time limit, so I'm skipping this. Independent sample t-test, right? So independent sample t-test, what is the problem? I would like to see whether the average depression score differs between the male and females. That what we were seeing based on the based on the box plot, based on the scatter plot, etc. and etc. Yes, what was the conclusion? Was it differ? Was it differ in the male and female, the depression score? Yes, based on the box plot and the data set which we were looking at that time, it says that it is differ, right? Let us see the again the box plot. If you remember, we have made this box plot, right? And this shows that the females patient have higher level of depression on average compared to the male patient. Right? Okay. This is just for the preparing the box plot. Let's go back and do the test, right? So we had applied here the t-test for testing the hypothesis. What is hypothesis? Does it differ in the male and female, or it's same in the male and female? So our null hypothesis, it's same in the male and female. The alternative, it differs, right? So this is the codes where we have stored the depression of male and female separately. Then t.test, male, female are the two data sets. Confidence level for 95, alternative two-sided, right? Wells 2 sample t-test is being applied, and you can see that the p-value is less than 0.05. It means that the null hypothesis is being rejected, and we can conclude that the depression level in the male and female are different, right? It's not the same. Also, you can see the mean of X and mean of Y is 31.50 and 36.18. So on the average level, which we are trying to test, significantly we can see that it's different, right? Okay, so this is the conclusion which we have already seen. This example is being done. Now pair sample t-test. What is pair sample? Anybody? When the sample is same, only the time is different, and during those times some technique is being applied, right? So for example, I would like to see that whether this workshop is going to create some impact on you knowledge wise, right, or not. So what is the idea? I could have taken a test before the workshop begins, and I could take the test before after the workshop begins, right? And that can be those two tests are, means marks of those two tests can be tested, right? This is called the paired sample test. So does the average depression score differs between the time 1 and time 2? What is time 1? At the baseline. What is time 2? After 6 months, right? So since they have been given a environment, the medical treatment, etc., etc., they want to test, right? So hypothesis is what? It's same. Null hypothesis is same. There is no difference. Alternative, it's differ. Again, t-test, medical depression 1, medical depression 2 are the two data. Two-sided alternative, paired 2, confidence level 95%. Paired t-test is being applied between the data depression 1, depression 2 with the 245 degree of freedom, 246 were the observations, and t-score is 11. Right? Sample estimate, mean of the difference 9.87. True difference in mean is not equal to 0. It means there is a significant difference between the depression score at time 2 and time 1. It means the null hypothesis is being rejected, right? That's how we can do that. Next is the ANOVA, right? Why we do ANOVA? Because there are multiple groups which is to be tested simultaneously. If there are two groups, we can use the t-test, right? But if we are more than two, we can use the ANOVA for simultaneous testing, right? In this case, when we apply the ANOVA, simultaneous testing, mu1 is equal to mu2 is equal to mu3 and so on, or h1, h0 is false. H0 is false means any of the mu1 or mu2, right, is not similar, right? That's what we mean. So what we do in this case of hypothesis, do substance group differ in their depression level, right? What were the substance? Anyone? What were the substance? Those three things which we were talking about: alcohol, cocaine, and heroin. These are the substance. So they want to see whether the depression is different between the or amongst the, in fact, these substances. We have already seen the graphs, right? And you must have remembered the output. Let us see here what can be done. Let us apply if you would like to see the tables in terms of the depression. So depression level in alcohol 34, cocaine 29, heroin 34, right? ANOVA, medical depression 1 with respect to substance. Dollar is being used to get the particular variable and the data sets. I hope you remember now, right? Fine. Here you see that the p-value is less than 0.16, means it's significant. So at 5% level of significance, we reject the null hypothesis that the depression level is the same across the three substances group, right? So that means the depression level in the three substances consumptions are different, right? We have already seen in the box plot and other things. The next thing is the correlation measures. So correlation is nothing but the relationship between the two variables which tell you about the association, right? The Carr-Pearson correlation coefficient is very popular coefficient which measure the correlations, in fact the linear correlations, right? And it ranges from -1 to 1. +1 is telling you the perfect level of correlation, perfect positive level of correlation. -1 is the perfect negative correlation, right? Okay, so if you would like to see here, what is the problem? What are the correlation among the depression, mental and physical assessment score? The average number of drinks and the age. So I just want to write here medical data, C, depression 1, mental 1, physical 1, average drink age. Which correlation? Pearson correlation, Carr-Pearson correlation. So you can see that these are the level of correlation, right? Depression 1 and age is the negative correlation. What does it mean? Age increases, depression. What happening to depression if it is negatively correlated? This data set doesn't show this, right? Depression 1 and the age is negatively correlated. So obviously if age increases, depression is decreasing, right? But since it is very, very low correlation, -0.013, it means it's either same or you may also say it's not decreasing, right? Very, very low correlation. If you see here, the physical one and the mental one, the correlation is 0.05. If you see here, the depression one and the mental one, a good amount of correlation but negative, right? Good amount of correlation but negative, right? So this is based on the data sets, right? Where you can find the correlation. So correlation can be used for only the two variables, for more than two variables, with respect to any one of them, right? Next is the regression. Regression is the method, right, where you are trying to establish the mathematical relationship between the two variables. If I'm talking about the linear relationship with two variables, the difference between the correlation and the regression is correlation tells you the associationship, right? Associationship. But regression tells you the cause and effect mechanism. One is the cause, therefore there is an effect. I'll give you an example. The sales of the ice cream and sales of the cold drink are the two things which increases in the summers. Nowadays, summer is going on, and you say that the sales of ice cream and sales of the cold drink is both are increasing. Both have increased. In fact, if you to get the data from 1 year, you will see that in summers it increases. But can you say that the cause of increasing the sale of the ice cream is sale of the cold drink? No, this is not the cause. What is the cause? Cause is the summer. Cause is the temperature, right? but there is a good association between these two. There is a good correlation between these two. So that is the difference, right? So whenever you would like to establish the relationship between the variables, mathematical, use the regression. Whether you would like to see only the associationship, use the correlation. So regression one, if I would like to see the mental one and depression one, right, model one, you can see that this is the intercept and this is the depression after running this model and printing this model. Summary of the model can get, right? Summary of the model will tell you that how the scores are. So these two are the significant, right? Means depression one is the significant variables in terms of the establishing the relationship between the medical one. It is contributing. Though the R square is quite less, right? The adjusted R square is also less. But in practical situations, usually the R squares are less because it's not only the depression which is going to affect your mental health, right? Even you are not depressed but your mental health is not very good. Is it possible? Yes, right. So that's why the R square is not very good, right? Though the model and the depression is the significant here, and you can do that. So for this one, we concluded that mental one can be written as 53.94 minus 0.6 is into the depression, suggesting that 1 unit increase in the depression score corresponding to minus 6834 point increase in the mental score at the baseline. Minus increase means decrease. So 1 unit of the increase in the depression is going to decrease the 68% of your mental score at the baseline. That was it, right? Similarly, using the regression, we can also use the multiple regressions, means there are multiple independent variables. So for example, I am interested to know the depression level, right? The mental, physical, average things are the three variables which is affecting, for example, because I have seen from the correlation table and I would like to see this model. These three are the significant variables: intercept, medical, and this. Whereas average things is not the significant variable here if you see this output here, right? So it means average drinks can be removed from this model. It's not going to affect. R squared little increase 52%, right? So you will see there was something 40. I'll see that again. 43% here, 52%. Why? Because one variable, physical one, is also added here, right? So two variables are going to contribute into the estimating the depression level, and that's why this is perhaps the better one, better predictions, better estimation using the multiple regressions, right? You can conclude here, mental one is a significant negative predictor of depression one. Physical one is a significant negative predictor of depression one. Average drink is not at all significant predictor of depression one. It means it can be removed from the model. Why is we used, right? R square 52 suggested that our model explains 52.4% of the total variation in the depression, as I said you earlier, right? So these are the few other types of regression which can be performed as per the requirement. Uh, these are the some links which where you can perform the R exercise for your understanding and for the different purposes, right? Thank you everyone. And this slide is being prepared by taking the help of the slide of Professor Okenbullet. I would like to acknowledge here and thank him here for this wonderful slides. So I'm just stopping my share here, and you are feel free if you have any questions.
Thank you, sir, for the highly informative and insightful presentation. The session is provided us with valuable perspectives on data handling techniques and the importance of visual. We shall now open the floor for questions. Participants may post their questions in the chat box or use the raise hand feature. We welcome your questions and interactions.
Please feel free if you have any questions, whether related to the concepts or something. If you are working on and you have some doubts, you would like to clarify anything.
Sir, I think the session has been really clear. So there's so it was really clear and explanatory, self-explanatory. And since you related all the concepts so well, I think there are no much questions as of now. But one participant has asked a question, sir. Can you share the presentation?
Yeah, sure. I'll share the presentations. Don't worry.
Yes, sir. Thank you, sir.
Thank you. If there is no questions, probably
Can we conclude the session, sir?
yeah, sure. Sure.
Thank you, sir. Thank you. So as we approach the conclusion of the session, we request all participants to kindly fill out the feedback form that has been posted in the chat box. And on behalf of our department and institution, I take this opportunity to thank the resource person for a very useful and an interesting session. Thank you so much, sir. And we also sincerely thank all the participants for their enthusiastic presence. As we continue our learning journey, we look forward to your active participation in tomorrow's sessions as well, which will be exploring further exciting topics on statistical computing and data analytics, etc. So, waiting for another day of insightful discussions and learning. With this, we conclude the session 2 of day 1 of our 3-day international seminar. Thank you, everyone, and have a pleasant afternoon, and see you all tomorrow. Thank you, sir, and thank you, everyone.
Thank you, sir, for a wonderful session.
Thank you, sir. Thank you for giving
Thank
me
you.
this
And very
opportunity.
clearly, you present all the concept related to our farming and their applications. Really appreciable.
Thank you. Thank you.
Yeah. Thank you, sir.
Thank you very much.
Thank you, sir. Thank you, sir.
So now we can close the session. I request to all the participants, please access the feedback form link.
Okay.
And
Just
submit the
allow me
same.
to log off. Thank you. Have a great day.
Yeah. Thank you, everyone. Thank you.
Thank you, sir.